Today, it is possible through genetic modification to adapt the structure of plants themselves. Supporters say this controversial GM technology could be the next scientific leap forward to provide the dramatic increase in yields needed to feed the world in the years to come. The United States has been growing and eating GM produce for almost 10 years with no apparent ill effects. But there are some who believe the claims made for GM are exaggerated.
My name's Corky Jones. I'm a farmer from Brownville, Nebraska, a little town in the southeast corner of the state. Been a farmer all my life, actually 78 years, and proud of every one of them.
8 years ago, along with thousands of other US farmers, Corky started planting GM wheat and soya, or GMOs, as they're known stateside.
It was just another thing printed on the bag that said something, but it didn't mean anything to the farmers, and didn't even know they were GMOs when we planted them, and didn't even know what the GMO stood for.
The companies selling GMOs to farmers promised high crop yields and a reduced need for chemicals to treat those crops.
Well, the first year we planted it, it was right. We sprayed one time, and it just so happened that it worked, and it worked well, that we held down the grass and weed population. The second year, why we weren't quite so lucky, we had to spray twice. And now, several years later, why we're spraying and putting other chemicals down to prevent weed infestation. If I was able to turn the clock back and say, okay, no GMO, and where we got now, I would definitely turn the clock back.
Corky is an exception. Most US farmers seem to have welcomed GM crops. For this small but vocal group of farmers and environmental activists who oppose GM across the world, the involvement of big business seems to be as much of an issue as the science itself. Concerns about the safety of genetically modified crops have turned into outright opposition even to field testing these new strains, especially in the UK and Europe. One of the world's top GM research centers is based in the east of England, where they're looking at the future of plant technology. Giles Oldroyd is trying to create new crops that will be less reliant on the chemicals that lie at the heart of intensive farming. In this experiment, he's trying to take the nitrogen-producing ability from pea plants and transfer them into wheat plants, reducing the need for nitrogen fertilizer.
This is a pea plant. On the roots of the plant, they have what we call nodules, and within those nodules are these pink structures on the roots. So those nodules are basically nitrogen factories, and they are supplying all of the nitrogen the plant needs for its growth. And in other plants that are incapable of doing this, they have to capture that nitrogen from the soil, and in our agricultural processes, we provide that nitrogen as nitrogenous fertilizer.
Nitrogen-based fertilizers can increase crop yields by up to 50%. So they're an essential part of the global food supply we all depend on. But the costs of using these oil-based fertilizers are likely to rocket over the coming decade, because oil itself will become more expensive. There is also an environmental cost to using chemical fertilizers, with evidence of nitrogen poisoning affecting soils and seas across the world. For Giles Oldroyd, these are all compelling arguments to push ahead with the kind of GM research program he is spearheading, despite the fact that many see GM food as unnatural or unpredictable.
Science, by definition, is predictable because it's not that we're just randomly taking a gene out of pea and putting it into wheat and asking what happens. We're actually very carefully, very thoroughly trying to understand the process in the pea plant. And then, with that knowledge and with that understanding, taking that into wheat. What we do know is the effect of nitrogen fertilizers. We do know that they cause death zones in the Gulf of Mexico. We do know that they're using huge amounts of fossil fuels, and yet we do them anyway. What GM has the potential to do is to make our farming far more sustainable and yet improve yields and reduce our reliance on the use of chemicals.
As well as enabling farmers to use less chemicals, this technology promises plants that can tolerate floods or droughts, that are resistant to disease, or that give higher yields. Scientists like Giles Oldroyd argue that we cannot afford to say no to genetically modified plants.
We're facing depleting natural resources, depleting fossil fuel reserves. We're facing expansion in the population to 9.5 billion. And we're facing climate change. And this is all going to happen within our lifetime. And if we are going to survive until 2050 without going into major wars and without having mass starvation, we simply have to accept that we're going to have to use this technology.
There are many advocates of genetically modified food and many critics. It has so far been a debate seen as a struggle between megacorporations and the smaller farmer, or between Frankenstein science and nature. The trouble with such polarized views is that it has prevented a proper informed debate about a science that could help feed the world. But perhaps this is not the only answer. Perhaps the key to feeding the world in years to come is as much about using our existing resources more intelligently. Maybe we need to consume or waste less food. Consumers in the developed world throw away about 1/3 of the food that they buy. And disposing of that waste isn't cheap either. In the US alone, it costs $1 billion every year.